Hi, welcome to COS 4550H, Module 2, and in this module we're going to talk about some background info which is necessary in order for you to understand what we're going to talk about in the rest of the modules. So what are we going to look at in this module? Well, we're going to look at John von Neumann's ideas about a self-replicating machine. This is kind of interesting in that if we can get machines building machines, robots building robots, and well, other than maybe coming up with Skynet, this could be something very, very useful. In fact, NASA sort of copied some of these thoughts with their plans in 1980 to send up self-replicating robot factories basically on to the moon and have these robots engage in some mining, building factories, and that sort of thing. Obviously, it didn't come about, or at least we don't know that it's come about, but it is still a very interesting idea. Next, we're going to look at the Turing machine. This is a finite state machine. Turing machines are basically universal computers. All computers theoretically are based on a Turing machine. And finite state machines are interesting in that we can use these in order to do many, many different types of things. One thing we can do is build cellular automata. Based on a cellular automata, we have cells much like a spreadsheet, and each cell is, in fact, a finite state machine. So we have a grid of finite state machines. Why these are interesting is these can display emergent behavior. The idea here is to take something very, very simple, apply a very simple set of rules, and get very complex behavior. As you'll see when you start looking at cellular automata, CAs, they can do some amazing things. We can even use them to add numbers, multiply numbers, display pictures, and all sorts of things. We're going to take a look at one-dimensional, two-dimensional, and more or less three-dimensional cellular automata in this module. So have fun. And if you have any questions or concerns, by all means, just send me an email.